Hello all. Today our video is going to be centered around dilations. Now, dilations is the fourth type of change that we think about just after finished transformations. Sometimes it kind of gets lumped in with transformations, so we have to kind of talk about them together. So a transformation is a translation or a slide, a rotation or a turn, or a reflection or a flip. When we do that too, or we perform those on a shape, we think about the fact that they don't change size. They're just moving around. Well, dilations is the opposite of that. It is exactly changing size. And when we change size, we have two options. We can be making the shape larger with an enlargement, or we can be reducing the size with a reduction. When we do this, we have a scale factor, which just means how much should we shrink it or how much should we expand it. We think about that as multiplication and as a simplified fraction. So let's just kind of jump in here. The orange shape is a dilation of the black shape. So the orange shape is a dilation of the black shape, meaning that this black shape is the pre-image and the orange is the actual image. So if we went from this shape to this shape, well, that got smaller, right? If it got smaller, then it's a reduction. And we want to know our scale factor. Our scale factor is this image over pre-image. So we're going to set up a fraction. And I'm going to think, okay, is there any side of my pre, any side here that would be easy to count out? And I look across and I'm like, diagonals are not easy. But here, this is easy. So how large is this, or how big? Think length, so 1 unit, 2 unit, 3 units. This has a side length of 3 units. The exact same side on the new image has a side length of 1. So we're looking at corresponding sides. 1 is a 3, the pre is a 3, the new is a 1. So our scale factor would be, well, we want the image. So the image would be the new, or the orange 1, and over the pre, and the pre-image was a 3. Now for a scale factor, that makes sense. Look, it's 1/3. It's less than 1. If we're making something smaller, it's going to be less than 1. It's going to be less than 100%. So yeah, 1/3 looks great. Let's look at a new one. Same thing, except now we have the green shape is a dilation of the black shape, okay? So the black is still the pre, and the green is still the image, or the new. So if I was here in the black shape, and I went to the green shape, did it get larger, smaller? Definitely larger, that's an enlargement. So we need to figure out by how much was this black shape multiplied by to get to the green one. That's what a scale factor is, it's multiplication. And it's multiplication in a fraction form that we're going to simplify. So I look for sides that correspond. It does not matter which ones you use because it's going to be consistent across the board. But we can pick ones that are easy. So if I look on this black one, I'm just going to use this one here. So 1, 2, 3. Now I have to find the corresponding side of the green. So if I use this 1, 2, 3, then I have to use this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So let's check that out. If we use our image over our pre-image, the image was 12 and the pre-image was 3. Well, 12 divided by 3, that we can simplify. 12 divided by 3 is 4. So my scale factor is 4, meaning I multiplied the smaller by 4, so 3 times 4 to get to 12. Now again, you get to pick the sides as long as you pick corresponding sides, which means, let's say I would decided, you know what, I want to do the bottom, 1, 2, 3. Well, if I did 3, knowing what I know, then this should be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is. Or you could have used the side over here. Pick the ones that's easy to count, and you'll be much better. Don't try to do the diagonals. All right, Let's try another one. Still looking at enlargement and reduction, the orange shape is a dilation of the black. So remember, the black we call the pre, and the orange is the new image. I'm looking for sides that are easy to count. Diagonals are not easy to count on a grid. Up and down is easy to count. So let's go ahead and look at the black one here. My pre, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Looks like 18. And the orange is 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to look here. Was that an enlargement or a reduction? Yeah, that orange is definitely smaller, so that's reduction. We're going to go image over pre-image. So my image is 9. My pre-image is 18. This will simplify. 9 and 18 will both divide by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. Therefore, this orange shape has a scale factor of 1/2. If I multiplied all of my sides, I would find that each corresponding is half of the original. Let's take a look at one more. The green shape is a dilation of the black. Again, our black here is our pre. Our green is our image. We're going to pick sides that are easy to count. So here on my black, 1, 2, 3, 4, 5. My image up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. From the black to the green, it got larger, so that's an enlargement. And I'm going to go image, my new, over my pre-image. My new image is 10. My pre-image is 5. Well, 10 divided by 5, well, that's an even 2. So I know that my size, I have changed by a scale factor of 2, meaning that I could multiply each side length by 2 to find the new side length. So dilations are different from transformations in that they change size. Make sure that you are careful with the words enlargement, meaning to get bigger, or reduction, meaning to get smaller. And then always set up your scale factor as a fraction and simplify.